Alright, so the question here in number 112 is the addition of hydrochloric acid to beakers containing solutions of either sodium chloride, up here, or silver nitrate causes a white precipitate in one of the beakers. Which one is it? Part A is asking which beaker contains the precipitate. Well, let's look at these. Can we logically look at these two equations and determine which one will contain a precipitate? Well, let's look at the first one. What are the players in the first one? Oh, sorry, let me rewrite this one here. Sodium. Okay, what are the players? We have sodium, okay, and then we have chlorine. Okay, and on this side we have hydrogen and then chlorine as my anion. So most likely we're going to have sodium and hydrogen switch spots. If they switch spots, what are we going to end up with? Well, we're going to end up with sodium chloride plus hydrochloric acid once again. So essentially we're left with the same thing, or no reaction. But now if we look at the second problem, okay, now the second problem, we do have a little bit more going on here. I'm going to change the colors for these just to kind of change things up a bit. Okay. Oops. So, and on this one we have silver as our cation, hydrogen ion, and these guys will switch in a double replacement reaction that we talked about earlier, leaving us with oh, that's not good. That's too light. Let's go with purple. No. Or blue. Okay. Leaving us with silver chloride, and that will give us a solid plus nitric acid. Okay, so, and this will remain as an aqueous solution. Okay, so, well, which beaker will contain the precipitate? Well, beaker number 2, the one that contains the silver nitrate. What is a precipitate? Well, the precipitate is the silver chloride. The silver chloride will end up being the precipitate. Okay? And then C, write the chemical equation showing the reaction, which I've basically just done here. Okay, and then classify the reaction, and that reaction would be a double replacement because, again, silver and this hydrogen ion switch places. Okay, and since I have two switching places with two other separate ions, my nitrate and my chlorine, this ends up being a double replacement. Okay. At first glance, this might seem like a trick question or one that you might not be able to answer, but if you just look at it logically, you'll notice, like I said on the first one, you're going to have a double replacement. If you were going to have a reaction, you'd have a double replacement reaction giving you the exact same thing. So in essence, you're not going to have a reaction at all. So it's kind of a trick question from number 112, and I thought I'd go over it just to help you guys out on the homework.